I'm just gonna document this idea before I go to bed. Um, I've been thinking about this idea for quite some time. I don't know if I've made a video about it though. And the idea is actually pretty simple. And it's not a new idea, it's not a novel idea. Uh, However, I don't know of a lot of facilities that are capitalizing upon this opportunity, which is a huge opportunity, considering the rates of consumption when it comes to coffee and tea in North America and across the world, particularly North America in the countries that have a colder climate. I think that's where the consumption of coffee is most prevalent. I think, I'm not sure. So I've taken a look at what's going on in Brazil, other parts of South America where the Amazon rainforest is prevalent. And every passing year, based on the imagery that's taken using satellites, the actual amount of land for the rainforest is uh, destroyed by loggers. So vast sections of the Amazon rainforest are being destroyed. Like the trees are chopped down, whatever's left is burned, and then when the fire settles down, crops are planted in its wake. So it's not an unfair assumption to make, or observation actually, that the consumption for coffee and other crops is what's driving the destruction of the rainforest. A similar kind of a reality exists in Indonesia and other parts of the world where there are rainforests. In Indonesia, what's happening is the rainforests are being chopped down for palm oil plantations. And palm oil is pretty much used in everything from potato chips to cookies to uh, pretty much everything. Like most of the snacks that you purchase at the store, I think palm oil is one of the main ingredients. It could be used in cosmetics, um, perhaps other chemicals, or day-to-day products like toothpaste. I'm not sure, but uh, these things are happening. Like I've looked at, uh, I have this in my notes. There's a video actually on YouTube. If you search for Amazon rainforest deforestation satellite imagery, these kind of videos come up. And the Indonesian rainforest getting wiped out is something that's been documented, and this is one of the documentaries that came out recently. I forget what the name is. I've only seen one episode of it. It has Harrison Ford in it. He's interviewing NASA scientists. It's not Before the Flood, which is Leonardo DiCaprio's documentary. It's the other series. So coming back to the idea, it's kind of late at night. I've been like kind of making a couple of these videos and watching a couple of other videos as well. I'm kind of tired. But the idea is actually pretty simple. What you do is you take a portion of the city, preferably in areas where the climate is milder. You could do this in the Sun Belt. You can do it in states like Arizona, where there's a lot of sun, or California at that. You can do it in Texas, any southern state, and from a North American perspective. You can do it across sections of South America. Huge landmass in Africa is like, you don't have to chop down forests for doing something like this. You can do it in Asia, you can do it anywhere really. You just need sunlight. So like I said, the idea is actually pretty simple, and it is to make use of vertical farming for growing crops. So, vertical farming, for those who don't know, is Peter Diamandis mentions this in his book Abundance, like just kind of showcasing some of the examples for what vertical farms. But imagine this is the actual arable land, and if this represents the surface area of the crops or whatever are being grown, then all the crops are grown on the surface of the land. So you need to have obviously land and topsoil, arable land, in order to be able to grow crops. So the crops, obviously, in most cases, grow underneath the surface, and then through the irrigation system, you have water supplanted to each one of the individual rows that's the crops are kind of planted in. So that's how we've done agriculture for pretty much since the advent of civilization, which, according to different estimates, I think I should know this, but I think this varies all the way from 10,000 years to perhaps 25,000 years. I think that's the range. I'm not too sure about the range, but civilization is a relatively new construct when it comes to the evolution of our species. Although there are some records today that there are Viking settlements or kind of remnants of the settlements have been found in places as far back as Alberta, and that was like before 20,000 years. Or actually, no, I could be wrong on the timelines, but there are reports suggest that there may have been other civilizations pre-Sumerian, and I don't think the Vikings were pre-Sumerians. I could be mixing something up. Anyways, it's late in the night, and I'm gonna get too stuck on the dates, but it looks like agriculture is an invention of civilization. Civilization has been able to sustain itself because of agricultural innovations, with more food reserves being stored. So there are avenues for using that time that has been recouped, which we didn't have before as hunter and gatherers. Not to that extent, and that time was invested towards the attainment of new knowledge through which civilization could sustain itself. Coming back to farming as a construct. So I just shared the example of how farming has been done traditionally. And now what's happening is there's something called the vertical farm. So imagine that plain kind of flat structure being replaced by something like that has columns. So imagine this bottle representing a vertical farm. And what you have is, instead of that one plane of land, which is, like it's affixed, it's very difficult to move a tract of land from one place to another. And you can only fit so many crops on that surface. But the limitation is the design, because we as a species inhabit the crust, or the top layer of the crust, actually. And I don't know what percentage of the earth is actually used for farming. I think it's a significant percentage of the landmass. However, it is a limitation of design. And if the vertical farming as a construct, as an innovation, is something that goes mainstream, then we can have a lot more crops in a relatively fixed amount of landmass. So imagine again that this is the landmass you have. I cannot do maybe I can move this a little bit. So imagine if this is the landmass, and now instead of that just one farm, we can fit so many of the farms. Whoops, my computer went to sleep. and I'm going to use the sriracha. Yeah, sriracha. So you've got like, imagine like farms upon farms, rows and rows of farms. And in the same landmass, same surface area, you now have so many different farms going up. And each one of those columns would be able to have crops. You could do vertical columns inside, or horizontal, or both. And there would be LED lights going through each one of these areas. There would be solar panels nearby or at a facility that is not too far away. There could be solar panels on top that are highly efficient, and they just redirect the sunlight through the LED system in order to be able to power the crops. So, using such a design, the net output when it comes to the crops is something that can be greatly enhanced, the output can be greatly maximized. It uses, right now, vertical farming, due to the very nature of its design, uses, I think, 99% less water for most of the crops. Because what happens with the land masses, with the water kind of irrigation system, and because of the propensity of the root system of most of the plants, they only have a limited amount of ability to be able to absorb the water. So the water kind of seeps through, and some significant amount of the water is lost. But with vertical farms, 99% of the water is saved, because we only need 1% of the water in order to be able to provide water to the plants and the crops. So there's a bunch of different ways. You could just have vertical farming done in some kind of a topsoil structure. So you provide the topsoil, and you got the layers, and the crops can be done in the vertical farms as they're done on the surface itself. You can do hydroponics, which is actually growing crops in water. It's a technique that's been in development for more than a couple of decades. I believe U.S. Army actually was using hydroponic farms all around World War II in order to be able to feed the troops. I think that's when it started. It could be earlier, it could be after. I'm not sure. But hydroponic farms are a successful technique. There's a relatively, I don't know how old this technique is, called aeroponics. Aeroponics is the ability to be able to grow crops in air. So what happens is you have, I'll just have this handy, so I'll use this. So imagine this is the plant, and what's happening is the root system is just kind of dangling in the air. And then you have a spray mix of water and chemicals necessary in order to be able to keep the plant healthy. It's like these are dissolved fertilizers, and the mixture is just sprayed directly in the roots. So the roots get their nutrients directly from that spray of water. So going back to what I started with in respect to the Amazon rainforest and the Sumatran or the Indonesian rainforest getting wiped out because of our consumption of certain crops. One of the easiest and most efficient ways, I believe, is through the procurement of vertical farms in some of the areas that I have identified. There could be others. If you look at Almeria, Spain, I believe that a significant percentage of the produce for a country in that region, I can't say which one, comes from a very tiny tract of land in Almeria, Spain. And this is a different system that they have in place. They're using greenhouses with white kind of roof cover, which I don't know how it really works. I didn't get into the details, but it not just cools the area around that location in order to be able to make the temperature ideal for growing the crops, if I remember correctly. It's been a couple of years since I saw that documentary. Sorry, excuse me. but it also leads to significantly higher crop yields. And there are some issues there with the workers' compensation and human rights. But this is toil, and these are the kind of jobs that machines can do. Um, but huge opportunity for engineers and designers to be tinkering with design and technology in order to be able to increase crop yields and produce crops that are not just pesticide free, but rich in nutrients at the same time. So, coming back to the idea, uh, I don't. I guess where this idea is different, and this is, I think, why it's probably worthwhile to make this video. I don't think that a lot of crops are being grown for coffee or tea in vertical farms. And this is what makes this such a amazing opportunity, because whoever can crack the code of growing these specific crops in vertical farms would do really well. Because we keep hearing about these ethically sourced coffee beans and perhaps tea as well, but we never really hear locally grown coffee beans or tea. And the reason is that there aren't really a lot of crops, at least in North America, for coffee or tea. But with vertical farming, you can control the temperature, the humidity within the facility itself. And you can provision, I think, the means to be able to grow these crops in vertical farms. And wouldn't that be great? It would start as maybe 1% of the global supply in the first 5 years. It would go to 5% within the next 8 years. It would double to 10% within the next 2 years. And then it's going to go to 20% within the next, I don't know, 2 years or 4 years after that. And it just kind of keeps building up on itself till eventually time comes that within a very short amount of time, 14 to 18 years, you have half, if not more, of the supply of coffee and tea being produced within the continent itself. And each one of the zones, or the continents are producing their own kind of supply. They have their own supply coming from completely sustainable means. The question is, there was a thought at the back of my mind about graphene, because I kind of envision, like, usually when the image comes up of vertical farms, it's a little unimaginative. It's really as a columnar, like structures like buildings, columns, like, circular, whichever, squares or rectangular buildings. What I was thinking is, and this is where biomimicry kind of comes in. And when I look at a tree, when I look at a maple tree outside, behind in the backyard, or any other tree at that, most of the trees, I kind of look at the Fibonacci circle, the golden ratio. I see a fractal pattern going in that tree, where it starts from a seed, and here comes a little bud, and then it slowly and slowly evolves to a higher pattern, with these concentric rings kind of going around the stem, turning eventually into a bark or the trunk, and then the whole thing kind of blossoms in order to be able to capitalize upon the resource that it needs in order to be able to sustain itself, which is to use sunlight to drive photosynthesis, which is in turn going to help the plant turn carbon dioxide into oxygen for the environment and for itself. nutrients that it absorbs from the earth, which it would use to sustain its own needs. So I think I got this idea from just kind of looking at trees. But I was thinking, what if vertical farms actually grew into a structure like that? And I wish I had a whiteboard right now. I could draw it out. But imagine you have a vertical farm that kind of has a base. It's not very. It's not like a base like this, right? It doesn't take that much real estate. So if this whole thing represents a vertical farm, which is, I don't know, anywhere from 20 stories high, which I have no idea how many feet or meters that would be, but it's pretty tall. And, it's whatever the width is going to be. Um, then what I'm saying is you don't need the structure to be like this. Um, with advanced materials, the structure could be a bit more imaginative. So imagine through some new material, whether it would be synthetic biology or whether it would be advances in graphene, that you have a super strong material emerging that would kind of grow. Like if this was the actual real estate being taken by the vertical farm, then the base is not that thick. It's not tens of meters in diameter. It's a very small base, maybe a meter and a half, 2 meters, and it just kind of springs up from the ground, and it's got a really solid base that the whole structure can sustain upon itself. And then it would have offshoots, and these offshoots will be quite a distance. They could spread out, tens of meters this way, each way. And these would be the columnar, they would be kind of like pads, lily pads, but like quite expansive. And you could do anything in these pads. You could like put topsoil, you could have hydroponic installations, aeroponic installations at that. You could have greenhouses, you could have stacks of vertical farms on a single base. So kind of like use computational design or be able to tinker with the actual designs so that it's sustainable, like the wind doesn't knock it off. They're even earthquake proof. There's ways to kind of do that as well, taking inspiration from the sequoia root system. But these structures would just kind of go up, and there would be all these columnar kind of structures or offshoots that would be coming off from the side, and maybe they would have their sub branches. And so using a very small amount of real estate, you could actually have you could have like hundreds of crops growing on a single tree. Or no, it wouldn't be a tree, it would be just like a structure. But you could literally have hundreds of crops, a lot of crops growing on a single stable structure. Now I mentioned graphene because graphene is super strong, and it is like thousands of times more stronger than steel, and it's like it's super light, based on what I understand. There have been limitations when it comes to the development of graphene because the process for creating it has required a lot of energy in order to be able to turn a lot of energy into a very small amount of graphene. But there has been a recent breakthrough, from what I understand, which allows graphene to be made in, I don't know how much more quantity, but basically the breakthrough has to do with introducing a spark, which I believe allows the molecules to melt. I gotta go through that document again, but it's basically the yield is much more efficient. There's something in my eye tonight. The yield is much more efficient when it comes to the development of graphene. I just look at myself. I'm looking tired by this point. But yeah, so like this is one breakthrough in graphene, and um, it's if it's ready for production grade after successive cycles of testing and safety and environmental considerations have been taken, uh, as in there's no leakage or seepage into the environment, then graphene is ready for prime time, and we can have structures like the one that has just been demonstrated. That is kind of like the idea of a vertical farm in my mind. I was like, just putting up a column or building, that's well and good. Another idea I have is that if it's LED lighting system, then we can put these structures on the ground, as is being done with some underground facilities in London, England, and perhaps other parts of the world as well. Um, Throughout the times, we've been kind of dependent upon sunlight in order to be able to grow crops. But now, with breakthroughs in lighting system and obviously the ability to be able to redirect energy, we can grow crops wherever we want. So that kind of puts the onus on, or sorry, that not the onus, but that kind of shifts the conversation towards materials. And this now becomes a question of materials. What kind of materials can we push in order to be able to procure newer designs, newer constructs through which the yield can be improved in order to be able to use less and less surface area in order to be able to improve crop yields. Energy, I don't think, is going to be an issue increasingly as we go into the future. In spite of everything you hear in the media, we are going towards energy abundance. We're on path towards getting to that state within 12 years, perhaps less, with the exponential rise of some of the technologies and subsequent, or some of the breakthroughs that have been mentioned. There are a lot more. And if energy is abundant, then we can grow crops wherever we want. And going back to the comment or the question I started with, I think the focus should be on shifting a percentage of the global coffee and tea plantations into the kind of constructs that have been demonstrated in Peter Diamandis' book, coupled with some of the ideas that I mentioned. None of these are novel ideas. I'm pretty sure there are others who have thought of these things, as in using new materials in order to be able to procure or manufacture farms of the future. It's just really the combination of ideas. There's this shell of the idea in my mind of how a construct like this would develop, and it's just really like, it depends on which kind of building material. If you use biology as a building material, then it would be like, I don't know, like some kind of a kind of sounds weird, but calcite kind of like a structure. I don't know if it's strong. It can be, depends on how you kind of organize it, and it would just like kind of grow, and then you can manufacture layers on top of that. I think, considering how much load is going to be on a surface like this, I think graphene is a better candidate. So with further breakthroughs, and I don't know how many years out this is, but with further breakthroughs in this domain, farms of the future could increase crop yields by some significant margins. And there's a bunch of ways through which, like the other problems are going to be solved. Like water is not going to be, providing water to it, the crops is not going to be that much of a problem. Anyway, so this is just my idea for using vertical farms for bringing a portion of the global coffee and tea plantations right here in North America and locally in other continents as well. Thanks for watching.